Hey everybody, and welcome to GoFormative number 48 on real numbers. So basically all numbers are real numbers. That's important to know. But all numbers are real numbers and they're something else. And the list of something else's are right here. Natural, whole, integers, rational, irrational. So all the numbers fall under real. And then some of them, all of them, are at least one other category. So this is a really cool chart if you know how to read this chart. So let me try to help you. On either side is irrational numbers and rational, meaning every number you see right here on the left side is irrational. It's classified as an irrational number, but all those irrational numbers are also real numbers. The definition of an irrational number is a number that does not repeat and it goes on forever. And I put some examples in here for you. The most famous irrational number is pi, 3.141592. Like, keeps going forever. On the other side is rational numbers. Rational numbers are all the numbers you see right here, including the integers, the whole numbers, the natural numbers. These are all rational numbers. Rational numbers, the main difference between, a huge difference between rational and irrational is these ones don't repeat. These ones are allowed to repeat. Like 0.33333333, that repeats forever, but it's rational, not irrational, because it is repeating. So both can go on forever, but this one is allowed to repeat. Also, differences, see how it says 1.89? That's just a decimal, nothing special. But this would mean it's a rational number because it's a terminating decimal. It just stops. It doesn't go on forever, so it's allowed to happen in the rational category, whereas irrational, it can only have numbers that don't repeat and go on forever. There's a little more flexibility under the rational. They can have the 0.33333 forever, and they can have a negative 0.25, a 1.9, a 3/4, which goes to 0.75. So underneath the rational classification are three more categories: integers, whole numbers, and natural numbers. I'll tell you this. Basically, if it's a natural number, it's greater than 0, 1, 2, 3, 4, 5. So 0 is not a natural number. 0 is actually a whole number. That's why you see it in the whole number spot right here, but you don't see it in the middle here, natural numbers. 0 is not a natural number. 0 is a whole number. What's the difference between natural numbers and whole numbers? The difference is whole numbers have 0, and they start at 0. 0, 1, 2, 3, 4, 5, 6, 7. Natural numbers start at 1. 1, 2, 3, 4, 5, 6, 7. So keep that in mind. The integers are basically positive and negative whole numbers, and they include 0 as well. So if I'm a natural number like 1, that means I'm also a whole number. I'm also an integer. I'm also rational, and I'm also a real number, which means, yes, some numbers can have more than one classification, more than two. So I'll say that one more time. The number 1 is a natural number, but it's also a whole number, it's also an integer, it's also rational, and it's a real. So it's got 5 things. Same with 2, 3, 4, 5, okay? Look at 0. 0 is not a natural number. It's a whole number. But 0 is also an integer, rational, and real. So 0 has 4 categories, 4 classifications, 4 spots it falls under. Integers. Take a look at like negative 1. Negative 1 is not a natural number. Negative 1 is not a whole number. But negative 1 is an integer, and it means it is a rational number, and it is real. So it's got 3 categories. And if you look at 1.89, for example, 1.89 is not natural, it's not whole, it's not an integer. But it is rational, and real. Just remember that everything is a real number. Okay, so let's try some out here. 8. Is 8 a rational number? Well, you can just kind of think about that for a second. 8. I see 8 right here. 8 is an integer, but it falls underneath rational, which means 8 is an integer and it is rational and it is real, but 8 is not whole number, natural number. But look at the question again. The question says 8 is rational, true or false? That's true. Is 4 an integer? True, because it says true right there. No, you have to go back and look. Visit this as much as you want. Look at the number 4. 4 is a natural number. But does that mean that 4 is a whole number? Yep, there it is. Is 4 an integer? Yes. Is 4 rational? Yes. Is 4 real? Yes. So 4 is like 5 different categories. So you'd be true on that. -3 is a whole number. False. So you want to go back to looking at your whole numbers. What's a whole number? Whole numbers start with 0 and they're positive numbers. So if I tell you -3, -3 is not positive. So -3 is not a whole number. And you can even see from the chart, -3 is an integer, which means it's not a whole number and it's not natural, but it is rational and -3 is real. I think you kind of get the hang of it. Here's another one, 3.15. Yeah, we just talked about that. Is an irrational number, true or false? It's actually on that chart. You can go look. Here's some more notes. These are actually like maybe definitions written out, things that I just said basically, but here for you, so you can look at them again. I know a lot of times we're listening and reading are two different things, so if you need to pause and read it or go over it, you can. And then it gives you questions. Basically, the questions that follow this are from this information. So I don't need to help you with that. You just need to read this carefully. All numbers are real numbers, yes. That's a fun one, matching. You're just going to match which ones go together. And if you don't know which ones go together, just revisit that very first image where it shows you all the categories and the numbers in them. This is fun to do, but you have to remember how to do. This is a unique problem. Look at the question, says which. It's funny. Match. That's it. You're just matching. So, for example, see the numbers 1, 2, 3, 4, 5, 6. Well, from the chart that we had, those were natural numbers, right? But didn't I tell you that natural numbers are also whole numbers, also integers, also rational, also real? I did say that. So that's why there's 5 things under here. So when you do this problem, you're going to have to drag 5 things into that one problem. When you get to this next one, it's not 5 things. It's only 4 things because look what I added here. What is that? A 0? And if I add a 0, which one of these disappears? But you can figure that out, process of elimination. So you're dragging all of them in, and that's your lesson, I think. I'm pretty confident. Review. This is all review, review, review. And then the last one is write at least one example within each category. And again, you can do it from memory. Try it. If you can't, you can look at the example I gave, the very, very front, the picture. All right. Thanks for watching Real Numbers.